Welcome. Here we're going to talk about net accumulation and kind of what we mean when we're talking about this. So let's consider a function here, and let's consider this to be a simple straight line. And this is going to be 60, and the units of this y-axis will be miles per hour. And I have 1, 2, 3. The units of the x-axis are hours. I will ask a very simple question, and that question is, if I have been driving at 60 miles per hour for 3 hours, how far have I traveled? So this question of how far or how much, this is a question of net accumulation. How much? How many miles are on my odometer? How much have I accumulated? So this is an intuitive problem. I have 60 times 3, that's 180. I've gone 180 miles. So I know that I have gone 180 miles, and I am approaching that using just kind of a logic-driven method. But I can also approach that using a more geometric-driven, which is to look at the area of this box. So the area under this curve, which is not, it happens to be a straight line, right? The area under this function, this change of rate function, can be found by multiplying the height, which is 60 miles per hour, times the distance, the width that I'm interested in, which is 3 hours. And when I do that, I end up with my units of being miles. So that's what we're looking at. We're looking at net accumulation is the area under your rate of change function. So you're being given a function that represents rate of change specifically, and then the area that is underneath that curve is in fact your net accumulation. So the thing that's important to note about net accumulation is that we can have more complex functions, of course, as always. But let's consider a scenario like this. Let's consider, I apologize. I want to draw this a little further up. Let's consider a function that has both a positive and negative component. It lies both above and below the y-axis. So let's say I leave work, I accelerate until I get on the or leave home, accelerate until I get the highway, I drive for a while, I decelerate, and I arrive at my destination, right? This is my velocity, so this is a rate of change function. I'll say that the units are miles per hour. And then the x-axis here would still be hours. At the end of the day, after I'm done with my work, I again decide to go home. This function is velocity, which means that if I defined going say north as the positive direction, the positive velocity, then when I am going back south, I have a negative velocity. So it would look like this. So as my day progresses, my net accumulation actually ends up being 0, right? And I've drawn this a little bit poorly. I apologize that the areas are not exactly the same. But if these areas are exactly the same, then my net accumulation would be 0. I ended up where I started, which is at my home. But you could be asked for any interval within that. I could be asked for, 0 to 3. This could be the interval that I am interested in, and I would represent that in a problem as 0 to 3. Or I could be asked for the entire thing. So you can be asked for any component of it, and being aware that if your area lies above the x-axis, it represents a positive accumulation. And if it lies below the x-axis, it represents a negative accumulation. And that is perfectly valid. You can get negative values. If I had a larger negative space, it would mean that I started, however many, say 20 miles further south than where I started. So it just depends on how you define the problem. But be aware that accumulation can be either positive or negative. So that is what we're looking at with net accumulation. You must specifically have a function that is a rate of change. So it needs to have those units, right? It could be gallons per minute, it could be miles per hour, it could be cells per day, whatever the situation calls for. But you're looking at a rate of change function, and the accumulation is the area under that function as you're working through the problem.